Hey everyone, welcome to my YouTube video. And in this video, I'll be talking about Kafka producer concepts, types of producers, its callback functions, various producer configurations, what are serializers and partitioning, and how to apply quotas and throttle your producer clients from your Kafka broker. So without any further ado, let's jump right into the video. And this is the high-level Kafka producer diagram. And before we jump right into this, so I'll just explain what a producer is. So producer is basically an application that publishes or writes data into your Kafka program, into a Kafka topic. And this data from your Kafka topic will be consumed by your Kafka consumer. So basically that acts as a reader and producer acts as a writer. Now let's jump into this diagram. So you can see that the producer record object will contain topic value, partition, and key, whereas topic and value are mandatory fields and partition key or optional fields that you can send it from your producer client. And topic is the name name of your topic, and values the message that you'll be writing inside this topic. And your topic can contain several partitions, and if you specify a partition, it will be returned into that particular partition. And key key is basically the key for the data that you're writing into your topic. So key influences the partitioning of data inside your Kafka cluster. And yeah uh, regarding the partitioning, I'll explain in detail when we go through the hands-on in the end of this video. Until then, I'll just explain the high-level components. So once you trigger this send API, this producer record will be serialized. So you will be writing your producer client in a high-level programming language such as Java, Python, etc. So this object, which is native to your language, needs to be serialized into byte of arrays, or you can say into bytes that has to be transmitted over your network. So the serializer will do the conversion process for you. Then once the data is serialized, if you have if you are sending the partition value, then by default the data will be returned to the partition that is specified by you. Or if you are sending it a key, then this key will influence the partitioning of your Kafka topics. So for example, if you have a topic named as location, and you have two keys, that is India and America, you have two partitions with respect to this topic, then the data that's associated with the key India will be written in one partition, and the data that is associated with America will be written in the other partition. So Kafka guarantees that as long as your keys remain the same, and as long as you don't increase the number of partition, the order and the data returned to these partitions will remain the same. That is, no data with the key India will be returned to the partition that contains the key America, unless and until you increase the number of partitions once you scale. After that time, only the records that are already existing in the current partitions that would be maintained, but new records, it is not guaranteed that the same key will go to the same partition. And the Kafka broker will send metadata that is a future object to your producer client API, which will be accessed by the callback function. So what is a callback function in software, or in software engineering? If you have programmed in a high-level OOP language like Java, you might have heard of what a callback function is. Nevertheless, I will explain what a callback function is. So once you a callback function basically calls another function within a function. So once you send your producer record, this callback function will will wait for a future object to be retrieved uh, by your Kafka broker. So once this future object is returned, your client will read the metadata, and in case if it is a retriable error, your producer record will be resent into the Kafka cluster. If it is a non-retriable error, then an exception will be thrown through this future object. And next one, constructing a Kafka producer. So you can see there are three mandatory properties on the screen that you need to construct a Kafka producer. One is bootstrap servers, next is key serializer and value serializer. So bootstrap servers is nothing but your Kafka clusters, the IP of your Kafka clusters. And if you're running in a cloud system with a VPN service or any other secure environment, if you're having, then you might need to pass the security credentials along with that, or the security certificates like SSL certificates, etc., along with your bootstrap server properties. And key and value serializers. So I've explained you what a serializer is. Basically, it converts your high-level objects into array of bytes or byte arrays. So basically, we are converting our key and value objects into bytes. Next one is methods of sending producer messages. So mainly there are three ways where you can send messages to your Kafka topics. And one is fire and forget, and is synchronous send, asynchronous send. So under fire and forget, you basically, your producer client will send messages into your Kafka broker, and it does not expect any return of metadata or exception from your producer from your Kafka broker. So what does this mean is that basically we are sending the messages, and in case if there is an error or a network issue where our message doesn't get delivered, we won't be able to know that. We are just sending our messages expecting they are being received by your Kafka topic. Synchronous send, in synchronous send, your producer client will send producer messages to the Kafka topic. Then it will call the get method to wait for the future object, that is the metadata or acknowledgement, to be received from your Kafka broker. Synchronous send is not recommended because Kafka is primarily used in asynchronous mode, both for producer and consumer. And if you are using synchronous send, it will adversely affect your performance, latency, and throughput in a production grade system. So only asynchronous send is the recommended way to design your Kafka producer or consumer application. Okay, the last one, asynchronous send. So in this case, we'll be sending our messages and then we will initiate a callback mechanism. That is, we won't wait until we get an acknowledgement or confirmation from your Kafka broker, but we will use this callback function to receive a future object from your Kafka broker, which will give an acknowledgement whether the message is being successfully returned in your Kafka broker or not. Okay. So for producer configuration, there are numerous producer configurations available. And here I've only listed out the important producer configurations that you need to keep in mind. But you're interested in deep diving into producer configurations for your applications, you could always check the Kafka documentation to see the various kinds of configurations that are available right now. So I'll be just explaining the important ones here in this video. And the first one is client ID. Client ID is basically a unique name or identifier that identifies the producer applications in your project or in your ecosystem. For example, a backend team might name their service as a backend producer service, and an analytics team might name the client ID as your data analytics team client or something like that. So it is just a unique identifier, and it helps in debugging applications on uh, where you receive and send data based on the client ID. You can use it's primarily just an identifier. And the next one is acknowledge, ACKS. Before I explain what acknowledge is, I would like to explain about ISR, that is in sync replicas. Uh, so in my previous video where I explained about the Kafka architecture and its working, I would have explained a little bit of ISR in sync replicas. Nevertheless, I will repeat what I said over there. So let's say in sync replicas. So in any distributed system, you need to have replicas of your data in case if one node goes down. You need to be able to serve requests with the available replicas. So by distributed system logic, you need to have your data replicated among various clusters. So in-sync replica means that, let's say you have one topic with one partition and your in-sync replica is 3. So that means that this partition is being replicated in 3 different Kafka brokers. So once you write messages to this topic using your producer, the leader of this in-sync replica will receive that data. And then once the data is received by the leader of the in-sync replica, this data will be written internally to the other 2 in-sync replicas by your Kafka broker. So there are 3 different acknowledge configurations in Kafka producer. You can assign 0, 1, or 0 means that it is a fire and forget mechanism where you just data into your Kafka topic and you don't expect any metadata or any future object return from your Kafka broker. If your acknowledge is 1, you will receive a future object in your producer client API once the data is returned in the leader in sync replica. If your acknowledge configuration is equal to all, then you will receive the future metadata only when the data is being written across all your in-sync replicas. So that is about ACKS and ISRs. Next is linger MS. So linger MS is the idea, is the time that your producer application will wait to before sending messages. Let's say, for example, if your linger MS is set to 5 seconds, then your producer client application will wait 5 seconds before it pushes next batch of records. The next property is batch MS. So batch MS is the size of, you can say the messages transported over the network is transported in the form of batches. So it is the size of network packets that is sent by your Kafka producer client. So this batch MS and linger MS are interconnected properties, and you must always configure them together to get your optimal performance. So let's say if you set a batch of 1 MB, then your linger MS to be 5 seconds. And if you have data of 1 MB in 3 seconds, then the Kafka producer client will send the data. And let's say if you have a batch of 2 MB and a linger MS of 5 seconds, and only 1 MB of data is available, and your 5-second threshold has passed, then 1 MB of data will be transmitted by your producer client. So these 2 properties are interlinked, and you should tune them together till you get your desired results. The next one is compression type. So Kafka supports various compressions like Snappy, gzip, and LZ4, etc. So compression is basically when you have a huge amount of data that needs to be transmitted, but you need to compress them beforehand to save network bandwidth costs. In such cases, compression type will be used. And the next one is max in-flight request per connection. So this controls how many message batches the producer will send to the server without receiving responses. So the higher the settings can increase memory usage while improving throughput. Next one is idempotence in Kafka producers. So idempotence is used to build exactly one schematic system. So what do I mean by that is that uh, you want to write data into your uh, Kafka topics, but you want to write them only once. You don't want to have any duplicates in your systems. So idempotent Kafka producers are here to address that issue, where you want to write your data only once, and having a duplicate in your system is highly undesirable. In such cases, idempotent Kafka producers are being used. So in order to have idempotence, your max in-flight request per connection should be less than or equal to 5, and the number of retries to be greater than 0, and your acknowledgement of in-sync replicas should be equal to all. So what do I mean by this? So don't worry, just the gist of is the gist of this is that you have to write data only once into your Kafka topic, and once we go to the hands-on part at the later part of this video, everything would be clear. Until then, just remember these three are the important properties to keep in mind when you want to build an idempotent Kafka producer. Next one is partitioning in producers. Uh, we have the default partitioner that when we are explaining the high level overview of a Kafka producer, I've explained about the default partitioner and its roles. So in addition to the default partitioner, Apache Kafka has round robin partitioner and uniform sticky partitioner. So let's say you're sending key value pairs of data over your Kafka producer. We'll take the same example that I've explained uh, when I explained the high level overview of the Kafka producer. We have a topic named as location, two partitions, one belonging to America and one belonging to India. So let's say we have a huge amount of data with the key as India. And in such a case, the volume of one partition will be very high and the volume of the other partition will be very low. So this causes skewness in our data. That is uneven balance between these two partitions. So in case if I don't want the keys to influence such kind of data skewness and when you're partitioning data, I could use round robin partitioner or uniform sticky partitioner to distribute data among these two partitions so that even volume of data is maintained across all my partitions in my Kafka broker. And you can also implement custom partitioning strategies for special use cases. Uh, so when uh, you need a special case where uh, you want to write data in a particular partition for a couple of keys, then you can use custom partitioning strategy as well for such use cases. And finally, quotas and throttling. So Kafka brokers have the ability to limit the rate at which messages are produced and consumed. So you might wonder, why is this even needed? As a developer developing a producer client producer client application or a consumer client application, why do I need quotas? So from looking at a software engineering perspective, as a like a development perspective, this might not seem like a very significant thing to be understood or learned, but from the administrative point of view, it is an important property to be discussed in the software design as well, because In case if your producer or your consumer application is faulty, where you might send a huge volume of data that occupies a lot of the network and CPU resources of your Kafka brokers. If there are quotas already enabled by the broker, then this can be prevented. This huge hogging of your network resources of CPU can be stopped if your quotas is enabled. So it is important to know about quotas and throttling. So quotas can be applied to all clients by setting default quotas, or you can set quotas for specific client IDs or specific users, or even both. So yeah, in short, it is important to plan and monitor to make sure that the broker capacity over time will match the rate at which producers are sending data. So what happens if there is no quota and if a huge volume of data is being sent by producers that the Kafka broker can't handle? So it will be in the client memory buffer. So if you send a huge volume of data, then your client memory buffer becomes full and it can cause some memory management issues in your Kafka cluster if quotas is not applied properly and if you're not throttling your data that is being received by your producers. So that is the end of the presentation. And now we'll do some hands-on programming in Python on how to build a simple producer application and how to enable idempotence as well. So I'm running a Kafka cluster in my Docker container. And if you see that, I'm running my Zookeeper and a single broker in my local machine. So how do I spin up a Kafka cluster? So uh, I have explained everything in detail in my previous video. And if you don't know how to spin up a cluster, you can just watch that video and see how do you spin up a Kafka cluster using Docker. So my Kafka cluster is running. What I'm going to do is I'm just going to create a topic here. So I'm just doing Docker execute of Kafka topics in my Bootstrap server specified. I'm going to create topic name application. And the topic is created. I'm just going to execute the list command here. As you can see, the topic location is created and visible. So what I'm going to do is I'm just going to run my consumer application here or the topic location. Okay. So let me enable my producer application. So I'm programming my Kafka producer application in Python. So I'm using the Confluent Kafka library and I'm importing the producer module. And this is the data that I'm going to send over the network into my Kafka topic. This is a JSON data. I'm specifying my name, email, and okay, name, email, and role. Name, email, and role into my topic. So this is a string. I'm just encoding this string into binary object. So basically serializing my string. This is my callback function. We'll get to that later on. Kafka topic name. So I'll just specify the topic that we created here. Location. Then in my configuration, I'm specifying my bootstrap servers. Then I'm creating this producer object here. So this producer object, I'm creating a poll. So I'm just seeing if there are any existing callbacks from previous producer calls. So if it is none, then we'll just directly go to this try except block. So I'll be producing data. I'll be using the produce method to produce data. I'm sending the key and value as well. Key is a string. You might be wondering, key should be serialized. That I explained that key and value should be serialized. If you look into this method by pressing control and going into the native Confluent library, you can see that in Python, you can send string or bytes for message payload and message key. So I'm just directly sending it as a string here. Topic name should be mentioned, key should be mentioned, value, and then this is my callback function. So let me just run this application. Starting Kafka producer, connecting to Kafka, wait until all messages are delivered. So message is delivered at my partition at offset. If you go look at my terminal, you can see I have received all my messages. My consumer data is written in the topic location. So this is the working of your producer, and producer flush will it's basically like it will wait for a metadata uh, from your Kafka broker, and so it should be at the end of your producer application. And if you keep calling flush every time once you hit the produce method, your producer application will become synchronous. So we don't want that as it adversely affects our performance. So producer flush should be at the bottom where your application is. We can enable idempotence and run this code as well. We can see the data is written. So in idempotence slide, I mentioned that ACK should be equal to all. So let's change this value and see if it works if ACK is equal to 0. See, it throws an error. So your acknowledge property must be set to all when idempotence is true. So if you want to enable idempotence, then your acknowledge should be all where all your in-sync replicas need to have the same data, and you have to receive an acknowledgement from your Kafka broker. So if this property is not enabled, you won't be able to enable idempotence in your Kafka producer. So I will leave the link in my link to my GitHub where all this code will be available. You could copy this code and you could tweak it and you could learn from this as well. So this is the complete overview about Kafka producer client applications. And in the next video, I'll explain about the Kafka consumer client application as well. So if you like this content or if you like these lectures, then do like, share, and subscribe.